Excel.
Hello viewers, welcome to the group presentation of our software engineering result. The experiment which we worked on was for level prediction for time series sequence. So let's start. Sequence and time series. A particular order in which related things follow each other. Sequence of events that occur in given period of time. As mentioned, example of time series event. Retail sales, weather forecast, power consumption, price of stock. Label and multi-sequence learning. The time series which is associated with an event is called label. For example, power consumption in kilowatt per hour. Power consumption, we are using data set of gym power consumption on hourly basis. The multi-sequence learning is based on STM classifier taken from neurocortex. STM can be used as type of neural network, and the system that tries to model the architectural detail of neurocortex is a neural network. So next part will be explained by my colleague Mandar.
Okay, so today we'll talk about objective. In nature, there are many events which occur periodically. So here we are trying to identify such time series sequence which is associated with a label, and the end goal is to learn the time series with the label and predict the given label at any point of time. So for our experiment, we selected power consumption data set of a gem. The association between time and power consumption is what we is what the algorithm will be learning, and at the given date and time, the power consumption will be predicted. So this is the a sample of our data set, where we have the date and time, and the next column is the power consumption. So there were only two columns in the data set. So talking about the approach, this is what we went through, like segmentation of the data, creating the multiple sequences, encoding the date and time as a segment, learn using the STM classifier, and then the prediction of the label. So the detailed explanation, this is the README file of the project where you will be redirected to, and the whole approach I'll talk in detail also as we move along. So talking about the segmenting data set, so there were two methods which we used to segment the data set. I mean, both of the methods are really same, but the data which we chose to create a segment is different. In both the methods, the segmented data is on 1 hour time frame, but in method one, what we have done is like so the refinement of the data is same in both methods, but the segment, if you see the segmented data, that would be different, and I'll show it to you guys. Like the format was in DD and YY. So sometimes, so there were, so it was not even an format, it was just single M and a single day which was mentioned. If there were 2 dates, then there were then it was in format. So we reformatted and added the padding to it. All right, and even in the R, we have done that. And while segmenting, we chose in method one, we have chose DD, YY, and HH. So as mentioned earlier, every data has been segmented on the single R time frame. And in talking about method two, we have chosen DD, HH, and DOW is nothing but the day of the week. So that's the only difference. We chose to drop the year because the year is same throughout the data set, and it did not give us much better results. I mean, when we switched on to method two, we'll talk about those results in upcoming slide. All right, so creating multiple sequences, what we have done is, like as mentioned earlier, there is each segment was of 1 hour time frame, and the sequences can be created in 3 configuration, that is a day, a week, or a month. So for our experiment, we actually chose to have only a small set of the whole data set. So we have chosen 720 segments. All right. And the configuration which was chosen was for a day. So what happens is like, if we chose a day's configuration, there are 24 segments in a day. And when if so, we have taken 720 segments. So that happens to be 160. So that happens to be 26 sequences. And if we I mean, the program is created in such a way that if someone wants to have a segmentation by week or by month, then we just have to change the configuration and the length of the data set, and we can have different type of length of the segments. All right. Talking about the encoding of date time or segment. So here we chose the scalar encoder of the NeoCortex API. Scalar encoder does nothing but it takes a numerical value and then it tries to encode it. So I mean, basically scalar encoders are for numerical values. So what happened is like we took the date and we broke down into its components such as date, month, year, the segment which is R, so and day of the week. All right. If you follow the link of demonstrated here, it takes you to the README file where the exact configuration for the scalar encoders are mentioned, are used. And as mentioned earlier, there were 2 methods, one which has year in it and the second one which has day of the week in it. All right. So this is about the multi-sequence learning, and my colleague Amar will explain you further about it. Thank you.
So talking about multi-sequence learning, multi-sequence algorithm, the multi-sequence learning is based on STM classifier taken from the NeoCortex API. In this algorithm, the connection is taken as per STM configuration. These configurations are responsible for the mapping to actual cortex of human brain. Spatial pooler is used to create a sparse representation of encoded data, and temporal memory is used to remember the sparse representation. There is also a cortex layer and STM classifier which gets trained model and predict the label. In this, the object of cortex layer to compute the SDR, the object of STM classifier to predict possible value. So in the result, to get the realistic value, we ran our program for 40 times, in which we got the maximum accuracy we achieved was 83.3%. So in discussion part, learning and predicting time series have been experimented for decades and various methods have been used. There were some hardware limitations running on local machine. To solve this in better way, the road of using cloud can be taken to scale up the learning process. Low accuracy seen due to small size of data set has been considered in the experiment. As seen while the run 744 segment took around 35 to 38 minutes to be trained. Also, long runtime was seen when more cycles were used. Thank you. That's it from my part.